Okay, so let's complete the guided notes and get some practice. We know a couple of parent functions already. We know our quadratic is y equals x squared. Our cubic, y equals x cubed. We know our linear, y equals x. No rational, which is y equals square root of x. We just finished up that test. And then this parent function, this is the exponent parent function, the exponential parent, has the form y equals ab to the x power. And we just talked about this. When b is greater than, when your base is bigger than 1, this is going to be exponential growth. When your base is between 1 and 0, you're going to have exponential decay. So we know linear, quadratic, cubic, and rational, and now we're going to add on exponential parent functions. We have exponential growth. Remember that means that your base is bigger than 1. And then over here, your base is between 0 and 1. This one right here is exponential decay. This one over here is your growth function. We're always going to keep these two separate, and here later on in the lesson, you're going to go through these two different functions because they have different formulas too. So this part goes pretty quick. When tell we that each function is exponential growth or decay. So, and then we're going to talk about domain and range. Alright, so number one is y equals 2 to the x power. Y equals 2 to the x power. I'm going to look at the base. Is the base bigger than 1 or is it between 0 and 1? So it's bigger than 1, so this is going to be exponential growth. We automatically know from our work on the do first that there's one coordinate point that will always be here. It's our y-intercept at 0, 1. The other coordinate point that we know is that when x is 1, y is the base. So we know the coordinate point 1, 2. We'll graph that, 1, 2. And there you go. So this is our growth graph. We're going to just connect the dots smoothly. You want both arrow markings on your graph, and notice that I never ever go below the x line. A really good example of this is how you can't have negative amounts of virus in your body. You always have to have like this positive part here. So your virus count should always be above 0, or maybe this is population or whatever. You're not going to have negative humans. You're going to always have like a positive amount. Domain and range is going to be the same. Domain is all real numbers. Your range is where y is bigger than 0. So the very last one let's take a look at is part B. This is exponential growth. Now we're going to look at where exponential decay happens. Exponential decay here. We're going to use decay again because we have a fraction here. It's between 0 and 1. That means we're going to use decay. It also means that we're going to have the same y-intercept. And the very last thing, when x is 1, y is 1/2. When x is negative 1, y is 2. So this is going to be how you draw this function. It's just going to come smoothly down like that, and then again, like the other side, it's going to rest on top of this x-axis like that. Domain is the same. All real numbers. As we go out over here, x gets smaller and smaller and smaller and smaller and smaller. As we go out over here, x gets bigger and bigger and bigger and bigger and bigger, all the way to negative infinity to positive infinity. On the range side, y has to be a number bigger than 0. Okay. So what we want to do now is stop, ask some questions, make sure that we have the graphing. The big points here. Do you know if it's growth or decay, and how? Do you have your coordinate point plotted? You need 2 or 3 for every graph. Did you make your arrow markings? Is it done right? If it's a growth graph, it needs to have a positive slope. If it's a decay graph, it's going to have a negative slope. And then write out your domain and range. 4 problems on the back I want you to get to. The substitute's just going to let you know if you're going to do it in groups or independent, okay? So go through 1, 2, 3, and 4, and we'll be back here in a few minutes.